Here we are, competing in an endurance race. Shannon cycled for 120 kilometers. Make sure everything's away that is sidetracking you at this current moment. And then swam for 12 kilometers. Okay? So we have cycling and swimming. So cycling and swimming. Now the key thing to these questions, Brady, put it away, please, is that we have speed, distance, time, or distance, speed, time, or whatever. But you will have all three. All right. Now, to fill these in, you will always have 4 givens. 4 of those boxes will be filled in from the information given. 2 of the boxes will be filled in using the distance, speed, time formula. So what often happens on a test is I can tell the ones who have practiced this or have listened, because 4 boxes will be filled in from the information, 2 from the formula. How do I know that people have practiced? The 2 from the formula are filled in. If they haven't practiced, they're just like, I don't know where to get these, and those are blank, and then they stop. Okay? So 4 from the question, 2 from the formulas. So here it says, Shannon cycled 120 kilometers. Where's that going to go under? Distance. So this is in kilometers. She cycled 120. And then she swam 12. Her average cycling speed. Now this is what we need to read. Sometimes they'll say something is 8 kilometers faster. 8 kilometers per hour faster. If that's the case, then you would do x plus 8. But if it says 8 times faster, what does times mean? To multiply. All right. So this one says her average cycling speed was 8 times faster than her swimming speed. So which one are we comparing it to? Cycling to swimming or swimming to cycling? Cycling to swimming. So swimming, we're going to make the x. Then what would cycling be? So 8x. If they said 8 kilometers per hour faster, it wouldn't be 8x, it would be what? X plus 8. Yeah, so you have to watch. Sometimes they say times faster, which means multiplication. Sometimes they say kilometers per hour faster. If they give a unit, like kilometers per hour, you're adding it. Okay? Now, Shannon took 9 hours to complete the race. Which time does that go into? Trick question. Neither. What is the total? Wait a second, there's 2 boxes that are empty. Now I must stop and never to carry on. That's what a lot of people on the test do. Remember, the 2 empty boxes will always come from the formula, using the other information in the table. So we are missing time, correct? So I know a lot of people don't like this triangle. I don't personally like it myself, but for this, I will use it anyways. So this goes alphabetical. D, S, T. Alphabetical from left to right. So if we want T, because that's the one that's empty, what is it? Distance divided by speed. So this time is 120 divided by 8x. And then this one is 12 divided by x. Now remember, we are in the rational unit. I know it's crazy. So we're probably going to get a rational out of this. Yes? A solving rational question. If you're like, oh, I can just do 8x plus 120 equals 7, is that a rational? No, when we're in the rational unit, so that would be kind of stupid if we did something that wasn't a rational in the rational unit. So a hint is, you need to set up a solving equation from rational. So we know the time it takes to cycle, it's 120 over 8x. We know the time it takes to swim, it's 12 over x. We know the total time is 9. How can we write out an equation? What can we write? 120 over 8x plus 12 over x equals 9. Not a hard equation to make, correct? Especially when they give you total time. Total time is the easiest one. Now what are you going to have to do? Find x. Go. Okay, so this one here, we have 8x. This one we're going to have to multiply by 8. And this one we're going to have to multiply by 8x to get a common denominator. So we're going to get 120 plus 96 over 8x equals 72x over 8x. What's 120 plus 96? 216 equals 72x. Before I drop off that 8x, though, x can't equal 0, which makes sense because x is speed, and that would be stupid. But also, okay. Divide by 72. What does x equal? 3 what? So, when we get x, I can go into the table and find a whole bunch of things now that I know x, right? Everyone paying attention? Okay. So, I can go up here, and I can put a 3 in for all the x's. So this would be 8 times 3, which would be, sorry, this should be, what the heck am I writing? This should be, oh my gosh, it's going downhill. This should be kilometers per hour, thank you. So this should be 8 times 3, which is 24. So what does that mean? 24 kilometers per hour is the cycling speed. Then I put a 3 in for x1, done. 3 kilometers per hour is the swimming speed. Then if I want to know time, I can go 120 divided by 8 times 3, which is what? Pardon? 4.5? 5? You have to add up to 9, so 45 won't work. And then 12 divided by 3 is 4. So this is time in hours, right? So 5 hours it took to cycle, 4 hours it took to swim. We agree? Now I can answer any questions it asks me. So let's go find out, because a lot of people just say, oh, x equals 3, and then they're done. Well, unless they're asking for the swimming speed, you're actually wrong, right? So what is it asking? Calculate her average cycling speed is what they want. So Shannon's cycling speed is 24 kilometers per hour. So just because you get x doesn't mean that's what they are asking for, right? They could ask for the time it takes to cycle. They could ask for the time it takes to swim. All of those are not just x. So you have to go back. I always go back, fill in my chart, and then I go answer the questions they ask. Because then I'm fully ready to answer anything they want. It also makes me double check. 5 and 4 equals 9. It makes you feel a little better that I didn't actually mess up. Right? Okay. Example 2. This one here says Holy Trinity's Council is traveling from Knoxtown to Harperville for the Student Council's National Conference. Based on the travel budget allowed for the trip, Holy Trinity's Council has 2 options. They can leave tonight by bus, or they can save 3 hours by leaving tomorrow morning and using the express train, which travels 25 kilometers per hour faster than the bus. 25 kilometers per hour faster than the bus. So is that 25 times faster? That would be aggressive. Okay? 25 kilometers per hour is x plus 25. The distance between Knoxtown and Harperville is 1,500. So the distance for both is the same. Makes sense. Determine the average speed of the express train and calculate how long it will take to travel between Knoxtown and Harperville by express train. You fill it in. So we have a bus, an express train, and you have speed, distance, time, or distance, speed, time. It doesn't really matter. I always just end in time. Distance is in kilometers, speed is in kilometers per hour, and time is in hours. All right. So So they both travel the same distance, 1,500, 1,500. Says the express train is 25 kilometers faster, not 25 times faster than the bus. So the bus is x, then this is x plus 25. And then the time you get from the triangle. So it's always distance divided by speed. So it's 1,500 over x, and this one's 1,500 over x plus 25. Now the catch here is they didn't give total time. Total time is the easiest one, right? You just add them up, set it equal. This one said that takes 3 hours, I believe. I can't remember. I can't find it. You save 3 hours if you take the express train. So a lot of people want to add 3 hours onto the bus or take 3 hours off the express train. Remember that we are trying to make these times equal. So this is the bus time, and this is the express train time. Let's think about it this way. If I want them to arrive at the same time, if I want the bus and the train to arrive at the same time, if they left at the same time, which one is slower? The bus is slower, correct? So which one would I take? So a lot of people want to take 3 hours off of the train. Well, now you just made the train arrive 6 hours faster. That's unproductive. I want, if we think about it, think about the bus is here, the train is here, correct? And I want them to arrive at the same time. So if I add 3 more hours onto the bus, are they arriving at the same time? If I take 3 hours off of the train, are they arriving at the same time? 3 hours off the train, now the train's going 6 hours faster. If I want them to arrive at the same time, I actually have to add 3 hours onto the train. Because the bus is here. You guys will always put it on the wrong one, just so you know. This is the bus time. This is the train time. If I want them to be equal, I have to add 3 hours onto the train time to make it arrive at the same time as the bus, correct? Because it's 3 hours faster. You guys always want to take 3 off of it, which makes it arrive even faster. So let's think about it in actual amounts. If the bus arrived in 6 hours, the train would arrive in how many? 3. So would subtracting 3 off of this make them equal? Which is what you guys do all the time? No, it doesn't make it equal. What do I have to do to this time? Add 3 to make it equal. Correct? You guys will also, the alternative that I get all the time is, people do this. They add 3 onto this side. Well, if I do it in numbers, you guys are like, no, that's stupid. Mrs. Lepp, you're telling me 9 equals 3. That's dumb. You guys do it all the time. You'll add it to this one. You'll add 3 onto this one, and you subtract 3 off of this one all the time, and they do not work. Yep? You could subtract 3 off of the bus to make it the same time as the train by, like, taking 3 hours off of it. Yep, that would absolutely work. So we could either add 3 to the train, or we could take 3 off of the bus, because we're trying to make their times be the same. So whichever one, this is how I think about it, so let's listen to me. If this doesn't make sense, at least make this make sense. Whichever is the faster object, add the time onto it to make them balance. Okay? Add the time onto the faster object. So if the express train is faster, add 3 hours onto it. Okay? If we're talking about a boat and a plane, if the plane is faster, I'm going to add the time onto that. So whichever one is faster, I add the time onto it to make the times balance. Okay? So in this case, the train was faster, so I had to add 3 hours onto it so that the bus and the train time are the same. The train was faster. It arrives there faster, so I have to give it more time in order for them to arrive at the same time. Like, thinking about it, I could take these 3 hours and I could go hit up a Denny's for 3 hours, get back on my train, and I get there at the same time. We agree? So that's why you're adding the 3 here, because the bus time is 3 hours slower. So I have to take my train time, sit in a Denny's for 3 hours, and then I can still get there at the same time as the bus. We agree? So we have to add that extra 3 hours onto it to make them be the same time. Does that make sense? So go to the faster time always and add the time to a faster object and add the time to it. If you're not given total time. Okay, let's solve it out. So this one is a harder one. I'm going to actually write it off to the left because I'm going to have to do quadratic formula or factor it because I'm going to get it squared. So I'm going to get 1,500 over x plus 1,500 over x plus 25. Sorry. I did it a different way. Equals. So you can either do it that way, or another way you could set up the equation if you don't like that one, is you could take the slower time minus the faster time equals 3. Which of the objects is slower? The bus. So you could take the bus, subtract off the train, and you'd equal 3 hours, right? So if I took the bus time and I took off the train time, I would still have 3 hours left. So that's another way you could write the equation. So the other way you could do it is bus time, subtract train time, and the extra time I have left over is 3. They're the exact same equation, just different written, right? Different order of the equation. So I could subtract this over and I would get that, right? Do I care which one you do? I care you do the right one. That works for your brain. So do that. Sometimes it's a multiple choice and you have to conform to the equation they have. But it doesn't matter. If I use this one here, this first one, I could just subtract that 1,500x plus 25 over and I get that one, right? So it doesn't matter which one you use. Just know that you could rearrange it to match a multiple choice if you had to. I want you to use the one that you get the right answer with. So sometimes people are really good at just taking the slower time minus the faster time equals 3. Some people like just being able to know that they can add 3, say, stop at a Denny's, and then they'll equal the same time. Okay? Up to you. I'm not forcing you into one or the other. I'm forcing you to whichever one gets you the right answer. Okay. So this one, I'm going to just go with this one on the left because it's sitting here. I would have to multiply this one by x plus 25. Now, some people want to just multiply by 25. If you multiply x by 25, you get 25x, not x plus 25. Remember, monomial, binomial, they can't be made the same. You have to multiply by each other as much as you would love to do it the other way. This one I have to multiply by x. And this one I have to multiply by x and x plus 25. Now, it's not bad or hard. It just means you're going to get a quadratic. So this one here, I'm going to get 1,500x plus, I don't know what that is.
37,500.
37,500? Over x plus 25 equals 1,500x over x plus 25. And then what I always do is I put these ones together, that 3 and that x together, and then I distribute them both in. So I go 3 times x, which gives me 3x, and then I go 3x times x is 3x squared, and then 3x times 25 is positive 75x over x plus 25. So then here we get 1,500x plus 37,500 all over x plus 25 equals 1,500x plus 3x squared plus 75x. Then the same as our solving. Once our denominator's equal, we can just set our numerators equal, correct? But we first have to study MPVs. These MPVs are kind of funny. X can equal 0, true, that's the speed. X can equal negative 25, true, that's speed. So, probably that they're there, but you're not going to get one of them anyways. Okay. Now, our denominators equal. Remember we did this? If these equal, then we can set these equal. So we're going to get 1,500 x, they will cancel, yep, you are correct. 37,500 equals 1,500x plus 3x squared plus 75x. When you have a positive one on each side, you could subtract it off, right? Then whenever you have an x squared, you have to get it equal to 0, and then either factor or quadratic formula. So we're going to subtract the 37,500 over. And you get 0 equals 3x squared plus 75x minus 37,500. Then I'm going to take a 3 out. So I get x squared plus 25x minus 12,500. So my a equals 1, because it's what's in front. This 3 is not anything in the quadratic formula. If you can take a GCF of a number out, just take it out, then you take the coefficients that's left. So a is 1, b is 25, and the reason why you can do that is if you leave the 3 in, you'll end up with the 3 in the numerator and denominator of your quadratic formula, and they'll just cancel off anyways. So if you take it out ahead of time, then you don't have to use as big a numbers in your binomial or in your quadratic formula. So a is 1, b is 25, c is negative 1 or 12,500. So we get x equals negative 25 plus or minus the square root of negative 12,500 squared minus 4 times 1. That is not true. That no one stop me. 25 squared, which is substantially better. B squared minus 4 times A times C. All over 2 times 1. Now, I always do this first, not with the square root, just the numbers underneath. So I'm going to get 25 squared minus 4 times 1 times negative 12,500. And underneath there, I get 50,625. I do not do the square root. I just do what's underneath. All over 2. And then this happens to be a nice one. So this could have actually factored. If when you type what's underneath the square root into your calculator and you get a nice number like 225, not a decimal, you could have factored this. If when you take the square root of something you get a decimal, you would have had to use quadratic formula. You could never have factored it. But because 5,620 or 50,625, the square root of it is 225, I know I could have factored it because that didn't come out as a decimal. So now we get two solutions. We get x equals negative 25 plus or minus. Oh, I don't want plus or minus. I want plus. 25 plus 225 all over 2. And then I get x equals negative 25 minus 225 all over 2. This one ends up being 200 divided by 2, 100. And this ends up being negative 250 divided by 2, which is negative 125. Now, what the heck does x represent? You should catch an error if you take these and put them back into your table, correct? So this x up here in the table, x represents the speed of the bus. Can the speed of the bus be negative 125 kilometers per hour? No, so I circle this one, and I say extraneous.
I guess their budget's not enough for them to take a flight. This should be long enough to fly.
Okay.
I don't know why I said that.
And then we're going to put the 100 in. And we're gonna get 100 here, and then here we're gonna get 100 plus 25, which is 125. And then this one we do 1,500 divided by 125. Which is 12. And then this one we do 1,500. Oh, 100, not 125. Oh, what? Okay. Nope. 15. Divided by 100. I don't know why I put 125. And then this one's 1,500 divided by 125, which is 12. Does it make sense? Is the bus going 3 hours longer?
Yes.
So it should make sense in the end. Okay, cool. We have all the answers we could possibly want. Let's actually see what the heck we need. So it says, determine the average speed of the express train. What's the average speed of the express train? 125 what? Yeah. So speed of the express train. Yep. You are correct. Is 125 kilometers per hour. And then, my voice just went through puberty. And then, calculate how long it would take to travel between Knoxtown and Harperville by express train.
Why? If it's like a flight, this would be like 4 hours.
It would super not be 4 hours.
7?
45 minutes, dude. My goodness. From here to Beast, like to Vancouver is a 45-minute flight.
It's like an hour and a half, actually. I should know I've flown to Vancouver, and then going into Hawaii, it's like an hour and a half.
Okay.
Then it was
Calculate how long it would take from Knoxtown to Harperville. 12. 12 hours. Okay. 12 hours for the express train. To travel from Knoxtown to Harperville.